Hi folks, this is Maria. Today we're going to review reaction types. So remember, you need to be able to identify and you should be able to sort out different reactions into different categories. So that's all I'm going to do in this video is just reviewing the different reaction types. So we've talked about 5 different reaction types during class at this point. You've seen it in the demos, you've done the activity in class. So there's synthesis, also called combination reactions, decomposition reactions, single replacement. We could also call those either single exchange or displacement. There's double replacement and double exchange, but is also a name for those as well. And then there's 2 different types of double replacement reactions that could also occur: precipitation or neutralization reaction. For a combustion reaction is also one of the options. So any of the ones that are highlighted that could be will be discussed as redox in a later video. So Becky will talk about that in the next video that you watch for chemistry. Combustion's in a different color because although Becky's going to talk about it, that's not one that we're going to be able to ever expect you to be able to see the redox aspects of that. So don't worry about that, but I just wanted you to know what's coming ahead as well. All right, synthesis. So when we're talking about a synthesis reaction, it's at least 2, could be more. You can have 3 elements or molecules, but when we're combining it into one product. Usually when we're looking at this, it's things that are solids, liquids, and gases. And when I think about it in terms of letters, it's always a format of A plus B going to AB. All right, so with these reactions on this page, one of the things I want to point out is that both of these reactions involve a diatomic element. That's not always true, but these were just some of the nicer cartoons when I was looking through. And the other thing that I want to note as well is that now, if you have not already started going back and reviewing your ionic naming, I would highly recommend doing so. So then remember that was back in Unit 3. You might want to go back and maybe even rewatch the video that we did in Unit 3. But that's just a suggestion. If you're like, well, how would I ever know that this is calcium oxide and this is magnesium nitride? Just a thought. Maybe going back and reviewing that wouldn't be a bad idea. All right. So for decomposition reactions, where a molecule or a compound is broken down to at least 2, could be more parts. Again, usually involving solids, liquids, and gases, and it takes the general format of A plus B going to A plus B. As you noticed in class, synthesis and decomposition reactions are pretty closely related. You could do essentially, you just take one reaction and then you flip it and you write the inverse, and you've come up with a decomposition reaction. So it's just sort of interesting. Just to show you that it's not all about metals with diatomic elements, here's hydrogen peroxide, which you've seen that reaction in class a few different ways now. Becky and I have used different catalysts, but it's just sort of interesting to take a look at. And here's a good one too. If you're looking at the calcium carbonate breaking down into calcium oxide and carbon dioxide, just kind of cool. All right, single replacement. So when we're looking at a single element, it's replacing an element in a compound. Usually it's a solid or a gas replacing within an ionic compound, where the solid or the gas that's doing the replacement is usually what we would call A in this, and then B plus BC, which would be our ionic compound. AC would be our new ionic compound, and then B would be usually a new solid or gas. Depends. So here's an example where a metal is doing the replacing. So sodium is replacing potassium in potassium chloride, and so that's why we end up with sodium chloride and then potassium by itself. Here's one, it's not balanced. I do want to point that out, but it's just visually pretty helpful to look at when you're seeing, okay, so this is a fluorine, and the fluorine ends up replacing the bromine and the sodium bromide, and so that's why I have sodium fluoride and bromide gas over here, or liquid rather, sorry. One other thing to be aware of, we're going to practice this more, but when we're talking about single replacement reactions, metals, when we're looking at this list overall, metals that are kind of like in this order, when you're looking at it, these metals up here can pretty much replace anybody, but if we're talking about any other like metals, so if I'm talking about the magnesium here, it would never be able to replace calcium. or if I'm talking about the magnesium here, I wouldn't be able to replace the potassium here. So this is sort of like if you keep on going down and down and down and down the list, it depends on the different lists, but you can see iron's kind of in the middle, and a lot of pipes that you know are used to be made out of iron. And I know this list doesn't show it, but copper is actually pretty far down here. And you know that a lot of plumbing is made out of copper piping. So it's just sort of interesting, but this is actually the reason why. So really what it means is saying like this reaction will happen. So if I have solid lithium reacting with magnesium chloride, it will end up getting a single replacement reaction. If I check my activity series of metals, I have lithium up here and magnesium down here. So that makes sense. Lithium can then bump out magnesium in the magnesium chloride. However, this reaction is not going to happen. So if I have lithium chloride plus solid magnesium, you can't go up that way. That's not going to happen. So there's no reaction that would occur. This also occurs when we're talking about the halogen nonmetals that are listed down there. The halogen nonmetals, if you even look at your periodic table, it's actually pretty clear why these are in the order. You're welcome to take a look at your periodic table as to why fluorine would be the most reactive and iodide would be the least reactive in another way. I do really want to make sure this is clear. You are not required to memorize the activity series. It's already on the back of your periodic tables that we use during class. So please use it. Just get an idea of how you're actually going to use this. All right, let's talk about double replacement. So where we have two ionic compounds and they're honestly just switching their cations and anions. Always with aqueous reactants, your two reactants themselves will always be aqueous, but depending on the type of double replacement reaction, maybe one of these ends up being a solid, maybe one of them ends up being a liquid, maybe one of them is water. It depends a little bit on the situation. But just as a general rule, again, something to kind of take a look at when we're thinking about these different ionic compounds. So to briefly talk about those special types of double replacement reactions, precipitation reactions is exactly what it sounds like. If I have a double replacement reaction and it produces one of them being a solid. So in this case, the silver chloride is what ends up being our solid in this particular precipitation reaction. Neutralization reactions are where an acid and a base react to produce water and a salt. And remember when we say a salt in chemistry, all that means is it means that I'm saying there's a metal and a non-metal as my final components here. Yes, in this particular case, I have sodium as my metal and chloride as my non-metal, but when we use the word salt in chemistry, it does not necessarily mean sodium chloride. Just to be aware of when you're looking for this, acids and bases, at this point, all you need to know is an acid that would have something like this, where there's an H in front, and then there's some sort of anion. And then a base would be where there's a metal in front, and then a hydroxide group at the end. There could be more than one hydroxide group, but it's just something to keep in mind. All right, so for combustion, so that's where a hydrocarbon and oxygen are end up mixed together, usually with some sort of heat, to produce carbon dioxide and water. When we're talking about the hydrocarbon molecule, that means remember that it's just something with carbon and hydrogen at the very least. Could also have oxygen being part of it, just something to be aware of. Then it's always reacting with its oxygen, then always producing the carbon dioxide and always producing water. Just remember as well, students sometimes get confused about this, the water is usually in its gaseous form because combustion reactions take a lot of heat. Just something to keep in mind. So for the last thing for your question that you need to attempt, so there's 5 different main categories of reactions that I've reviewed in this video. So when we're thinking about it, our single replacement, our double replacement, combustion, synthesis, decomposition. So those are the 5 main categories of these reactions. Well, I've written out a bunch of different reactants and products. Write an example of each of those different types of equations using these reactants. Don't go back through and pick on something that I showed as an example. We want you to try and do it using these. So you can go through and come up with at least one equation for each of these You don't have to come up with more than one, but I'm just saying there's more than one possibility with the things that I provided here. And you can use any of these substances more than once when you're going through and writing out your 5 different equations. All right. Well, we will definitely go over that, and I'm excited to see what you come up with. Hope you have a good night, and we will see you soon.